Hey guys, today we will learn about the rotation, field, and synchronous speed. We are kind of confused about this concept, right? But first of all, you need to remember one thing. No, two things. You don't need to the process. You just need to the memorize it. It's also fine. The result, you know what I mean. And then it's better, if you understand this mechanism and process. And And as I said several times, the current and the magnetic flux is the same, right? Uh, it's a differences is only dimension, you know what I mean? So for example, if I'm current is me, magnetic flux is magnetic field is uh, meter, inside of a meter, like we, appear at the same time and disappear at the same time, right? But we are same, but different dimension, right? I cannot touch him and he cannot touch me, right? That is the important concept. So let's see. So the result is, as we know, we use a three-page system, right? Since we use a three-page system, and then the result is we need power in the, source, and it made a magnetic flux, right? Magnetic field it made, right? So let's see the direction, how we make it. So first of all, I will separate this part is here. Mm. Okay. And then this is 0, and this is 1. Mm. I'm sorry. This is 2 and 3, 2, 1, 0, and then 4, 5, 5, and 6. No, happened. Sorry, guys. Yeah. Okay. There's 0 and there's okay. 1, and then 2, and then 3, and then 4. So let's see. This is 90, 180. Yeah, add the 90 degrees here. You guys can see, right? So as I said, uh, you know, for example, if the current is here, right, flowing this dump way, the magnetic field is this way, right? If the current is way, the magnetic field is this way. We already know, right? So with this concept, we will see. First of all, here, which means it's come out, and plus, and this is in and minus, I will say, okay? So first of all, we see here. We will see just the direction, okay? And this is A, B, C phase, just a 1, 2, 3, okay? So first of all, what happened in 0 degree here? 0 degrees, base 1 is 0 here, right? 0. And then B is, what is that? Phase B, purple is minus here, right? X. And third is here. Page 3 is the blue is plus is coming out here, right? So let's see. For example, so draw this. One, one, two, two, three. This is say 1 and 2 and 3. 1, 2 zeros, degree differences. And this is the other side is a return between 180 degrees differences. You know what I mean? The coil is like that, but between them 180. Between here, return and in. You know what I mean? Current is need to go to this way, right? So let's see. This color is not good. Okay, let's see. First of all, at 0 degree, we don't consider A, right? Single phase, phase 1, right? And B is, where is it? Here, minus, right? Here is minus in. And what about 3 is, page 3 is plus, out, right? So which means here's in, here's also, return is out. So which means, look at that. X is inside, right? And this dot in the circle in the dot, this is out, coming out from the monitor to me, this side. And X means here, from my side to monitor, inside going, right? So my finger, look at that. Inside and then going out. This numbers 0 point, T 0 point is, look at that. I'm saying, yeah, 0 point. Magnetic flux is here, right? And then second, what happened here? First, 9 degrees. What happened? Page 1 is now in, out, right? Plus means out, right? It's out. Yeah. Let's see. And then what is that? Both of them are minus, right? Minus means in, right? Here, right? And then the out is here. The return is a reverse way, right? So look at that. Inside and outside, right? Look at that. My thumb is now this way. Inside and here, right? Thumb is now. Second is this way, right? And look at that. Now this time. And what happened? 180 degree here. This part. 180 degrees. What happened? Page 1 is 0, right? So we ignore here, and then 180 degrees here, right? And then only page 2 is plus, right? Page 2 is plus, which means out. Page 2 here, right? It means out here, right? Which means that the other part is written is X, right? In, out, right? And 3 is, where is it? Page 3 is, the blue is also here. 180 degree. What happened here? This part. Minus, right? Minus means X and in. So look at that. So which means, look at that. Here's this part in, and coming out this way, right? Out is here, right? So which means my thumb is 2 parties. What happened here? Right? Look at that. And what happened also? Yeah, green one. So 270 degree. What happened? Let's see. Okay, 270 degrees here, right? This point. So look at that. What happened? A is minus, right? Which means X. The other side it need to come out here, right? And both of them here. What happened? Both of them are plus. Plus means X. And here's minus, right? So look at that. What happened? You guys can see here. Sorry guys. Here it gotta be here. Dot and X. Sorry, because look at the here. page 2 and page 3 is yeah, kind of messy. But if we follow here, you guys can see. And this is plus means out, right? It gotta be out here and here. And the other side, X. So look at that, what happened? It's from inside this side, right? In, and this is out. In, out. What happened? Now. So I was saying is, look at that. What happened to my thumb is it's gotta be like a rotating, right? We will say this is a rotation field. You know what I mean? So yeah, we will say in the 2 or 4, we say this is fast speed. You know what I mean? High speed. And over the 6-4, to 60 or something, yeah, like lots of force. We will say not high speed for. You know what I mean? So yeah, this is a rotating field, the mechanism, and yeah, this is yeah, this part is kind of complicated, but you guys can understand, right? So you guys just don't need to understand this. Just remember, yeah, when we power on the 3 phase, it makes magnetic field to rotating. That part is important, right? And then let's see. Yeah. So the second part is just synchronous speed. So what is a synchronous speed? So look at that, guys. First of all, the result is, I will say, synchronous speed is, voltage source speed. For example, look at it here. There's A, B, C source coming. And then, just for example, I will don't. This is inside the magnet. This part is a rotor. And this outside is a don't move part is a stator, right? So motor and the generator is almost the same. Well, what I mean is just a mechanism. It's make it electricity or it's use electricity, only differences. Look at that. So for example, generator, when here's a prime mover, right? So here's something with energy, like for example, hydraulic or solar power or wind power. It's rotating this part. You know what I mean? This shaft, it's rotating, and they make it to outside. Make it electricity is a generator, right? Simple concept. And what is that? The motor getting power from here, and then this part, this rotors, it's making something worse, right? Make it worse. It's make it rotating, right? Our road. This is a motor's concept, right? But the thing is, we already learned about the here the rotation field, right? When the current is coming, the field comes out, right? Automatically. So what I meant is the synchronous speed is, it's a voltage sources hertz is voltage sources hertz is synchronous speed. You know what I mean? For example, here's a pluggers 60 hertz, right? 60 hertz. So which means 60 hertz here, 60 hertz multiply and 2 pole. The standard is I will say 2 pole. It could be 4 or 6 piece. So which means 3600 RPM. This is I would say is synchronous speed. The voltage sources hertz is synchronous speed. So what's the rotation field? Rotation field is here. when it, the rotor is rotating, it also rotating, right? But because of load or something, it's a fraction or it's something disturbed or whatever, right? Lag of power. So it cannot, rotate the same speed from the up voltage. So which means this is if it's a difference just between the speed, you know what I mean? Rotor magnetic rotation field and synchronous speed differences, we say slip. But synchronous, which means this speed is the same. To make a rotor's field and the output heritage the same, we say synchronous. For example, if it's a 3600 hertz, it's also make it, and the source is 3600 RPM. We say this is synchronous, same. But if like 3400, we say this is not synchronous. So between them, we say sleep is happened. You know what I mean? Yeah, it's kind of easy or still confusing, right? Still a little bit, but just the result is just I said rotating field is always happened because of the when the current is coming through, it's a magnetic field is making, right? We see it, right? It's rotating, right? And then synchronous speed is the output, no, the voltage source is hertz. If the rotating field is, rotating speed, like if we make it 3600 and then the output, not output, the source is 3600 hertz, same hertz, we will say synchronous. If the difference is there's, it cannot be always the same. Almost the same as we say synchronous speed, you know what I mean? If it's a kind of a difference, yes, we say slip. Yeah, I hope you guys can understand that. Yeah, today's lecture is done, guys. Yeah.